Welcome to The Explainer. We're going to tackle a pretty wild question today. Is it possible that the stress your great-grandmother went through could actually be physically passed down to you? We're diving into the science behind this incredible idea of a biological echo that can ripple right through a family line.
I know, it sounds like something straight out of science fiction, doesn't it? But this is a real, profound question that scientists are finally starting to get answers to. They're digging into how our life experiences, the good and the bad, don't just vanish. Instead, they can leave this physical mark, an echo that travels across generations, actually shaping the biology of people born decades later.
Okay, so let's be super clear. We're not talking about, remembering a story your grandma told you. This is way deeper than that. We're talking about a physical imprint on our body's systems. It's a concept called biological memory, and it's the idea that the hardships of the past can literally get written into our very cells.
So on our journey today, we're basically going to follow this amazing scientific detective story. We're going to look at the clever experiment that first created this echo. We'll trace its effects through 3 whole generations. Then we'll uncover the exact biological culprit responsible for it all. And then, and this is the incredible part, we'll see how scientists figured out how to just flip a switch and turn it off.
Okay, so how on earth do you even start to test an idea this big? I mean, where do you begin? Well, it all started with a really clever experiment, one specifically designed to isolate the effects of stress and see if it could really travel across generations. See, to do this right, they couldn't just use any old stressor. They needed to simulate a very particular kind of stress, that subtle but kind of constant instability you might see in early life. And to do that, they developed a really precise method. And this is what they came up with. It's called the Repeated Cross-Fostering Experiment, or RCF for short. So here's how it worked. For just a few really critical days right after being born, little mouse pups were moved to a new adoptive mother every single day. Now, this wasn't some big traumatic event, but it did create this subtle, nagging instability in their care, a mild but constant form of early life stress. And then, after just those 4 days, everything went right back to normal. So here's the million-dollar question. Did that tiny, brief period of stress actually have any lasting effects? And more importantly, would those effects show up not just in the pups who went through it, but in their children and even their grandchildren, all of whom were raised completely and totally normally? To figure that out, the scientists decided to focus on 2 of the most basic, fundamental defense systems that pretty much any mammal has. First, how the body reacts to feeling like it can't breathe. You know, that gasping, panicked breathing. And second, how it reacts to pain. I mean, these are super basic, hardwired survival responses. And the results were, well, they were absolutely striking. When they exposed the mice to air with high CO2, which kind of mimics that feeling of suffocation, the mice from that stressed family line had a way stronger, more panicked breathing response. But here's the kicker. It wasn't just the first generation. The exact same effect persisted through their children and their grandchildren. And get this. The exact same pattern popped up for pain sensitivity. It didn't matter if it was a heat source or just a little physical poke, the mice from that stressed lineage yanked themselves away much, much faster. It's like their internal alarm system was just permanently stuck on high alert.
Okay, so this is the absolute key takeaway right here. This heightened state of alert was passed down from the original mice, the ones scientists call the F0 generation, all the way down to their kids and their grandkids. And since all those descendants were raised in a completely normal, stress-free environment, this couldn't be learned behavior. No way. It had to be something they inherited.
So if this stress response is being inherited, right, there's got to be some kind of physical mechanism that's carrying that memory forward. So the question becomes, what is it? What's the specific molecule, the biological culprit, that's passing this message down? The hunt was on.
Right, so the scientists basically turned into molecular detectives. They started this massive search inside the brain's neurons, looking for one specific molecule that could be the thing, the carrier for this generational message of stress.
And their investigations started to zero in on these particular proteins called acid-sensing ion channels, or ASICs for short. Now, the absolute best way to think about ASICs is like this. There are tiny little biological alarm systems living on the surface of your nerve cells, and when they detect a change in acidity in your body, which is a huge danger signal for things like suffocation or tissue damage, they're the ones that fire off the warning. And this is where it gets really interesting. They found that the number of these little ASIC alarms was cranked
way up in the mice from the stressed lineage. But here's the thing, it wasn't everywhere in the brain. They were turned up specifically in the two areas that control breathing and pain. It was a perfect match for the symptoms they were seeing.
Now, this was a massive clue, right? But as any good scientist will tell you, just because two things happen together doesn't mean one caused the other. To really prove that these overactive alarms were the true cause, they had to do one last, really dramatic test. And the question they asked was just beautifully simple. It was, if these overactive alarm systems really are the problem, what happens if we find a mute button? What if we could just temporarily turn them off and see if those inherited stress responses just vanished?
So using a drug called amiloride, which they knew could block these ASIC alarms, they did exactly that. They gave the mice a single inhaled dose, and the results were just astonishing. That panicked, hyperbreathing response to CO2, gone. That super high sensitivity to pain, vanished. The mice's reactions just completely reset right back to normal.
I mean, this was the smoking gun. It was the proof. It showed that these specific ASIC channels were the physical mechanism that was holding on to and passing down this echo of stress across generations. Think about that. A biological memory, passed down for 3 generations, was wiped clean, even if only temporarily, with a single dose.
Okay, so this is all really fascinating in mice. But why does it matter so much to us? What does a study about a mouse's first few days of life have to do with humans? Well, it turns out the connections are surprisingly direct and really important.
Well, let's connect the dots. First, we know for a fact that early life adversity in people is a massive risk factor for things like anxiety and panic disorders. Second, we know that one of the absolute hallmarks of panic disorder is an extreme fear of suffocation. That's the very same CO2 hypersensitivity they saw in the mice. And finally, to top it all off, the human genes for these exact same ASIC channels, they've already been directly linked to panic disorder and pain sensitivity in people.
So when you put it all together, this isn't just some cool science story. It's a potential roadmap for the future. By pinpointing a specific physical target, this research cracks open a whole new door for developing treatments. We're talking about therapies, maybe even using existing drugs like amiloride that could help reset those brain systems that get stuck on high alert because of early trauma.
And that leaves us with one final and maybe more hopeful thought to chew on. If the biological memory of hardship can send an echo down through the generations, couldn't the same be true for resilience, for strength, for positive adaptations? Now that is a story that science is really just beginning to explore.